Hey everyone, and welcome to RUBIN'S MindLab, where we break down the latest research into what it really means. Ever wonder why sometimes you just can't shake a wrong belief, even when the facts are staring you in the face, or why you might be super confident about something, but still be wrong? Well, this new study digs into the very heart of how we think and why our reasoning can go off track. Imagine you are trying to figure something out. You've got different pieces of information.
Right.
Some of that information might be the factual background, like the odds of something happening, and some of it might be a gut feeling or a stereotype. This study looked at how we weigh these two kinds of information when we're making decisions, especially when they disagree. They call these things base. Rate information and stereotype information. Think of a classic example. There are 997 lawyers and only 3 engineers. If you meet someone who loves math puzzles, it might feel like they're an engineer, even though the numbers say they're almost certainly a lawyer. That is base rate neglect. Scientists have been trying to understand this for a long time. A popular idea is that we have 2 ways of thinking. One is fast and automatic, like a gut reaction. The other is slow, effortful, and logical. When we make mistakes, it's often thought to be because we either don't notice a conflict between our gut feeling and the facts, or we notice it but can't correct it. But the researchers here asked if there is a deeper reason for these failures. They think both problems might come from the same place. A faulty signal in our brains that guides our choices, how confident we are, and how long we take to decide. So how did they test this? They had 151 people do a kind of reasoning game. For each round, people were given a description of someone and told the general mix of 2 groups they could belong to, like clowns and engineers or nurses and politicians. They were given both the base rate, how many of each group there are, and a description of the person's traits. Then, they had to guess which group the person belonged to. What is cool is that the researchers used fancy computer programs called large language models, like super smart AI, to figure out exactly how strong each stereotype was for the descriptions they used. This let them carefully control and mix and match the stereotype information and the base rate information in their game. Now, what did they find? Well, it turns out most people don't give equal weight to the facts and the stereotypes. The study found that participants heavily favored the stereotype information over the base rate information. When researchers looked at the choices people made, how confident they were, and how long they took to answer, it all boiled down to this biased weighing of information. Even when the stereotype description was weak, it still had a bigger influence than the solid factual base rate information. This is where it gets really interesting. The researchers believe that this biased weighting creates a latent evidence signal inside our minds. This signal is what actually drives our decisions, our confidence, and our reaction times. So, if you heavily lean towards stereotypes, your internal signal will be skewed. This means you might make a wrong choice quickly. Feel very confident about it, and then find it hard to change your mind, even with more information. The study showed that people who relied more on stereotypes for their choices also showed greater confidence and faster reaction times when that stereotype information was stronger. This suggests that the same internal, possibly skewed, signal is influencing all these aspects of our thinking. To really nail this down, they built a computer model based on something called a drift diffusion model. Think of it like a little decision-making robot. This robot collects evidence over time for 2 options until it hits a certain threshold and makes a choice. The key is that in their model, the drift rate, how fast the evidence builds up, is based on that biased weighing of stereotype and base rate information. If the evidence signal is skewed, the robot is more likely to quickly drift towards the wrong answer, even if it is a wrong answer. They tested 3 versions of this model, one with a fixed threshold for making a decision, one where the threshold got bigger if it detected conflict, and one where the threshold lowered over time. Guess what won? The simplest model, the one with just a biased evidence signal and a fixed threshold, explained the data the best. This means that the idea of a biased internal evidence signal driving everything was the most powerful explanation for their findings, without needing extra complexities like the brain actively deciding to think harder when it senses a problem. A really crucial finding was that the strength of someone's bias, how much they leaned on stereotypes, wasn't related to how cautious they were in their decision. Usually you'd think that if you are really biased, you might be more deliberate and cautious to avoid mistakes. But here, they found no link. This suggests that people who are strongly biased aren't necessarily holding back or trying harder. Their internal evidence signal is just structured differently. They visualize this biased evidence landscape. For an unbiased thinker, the evidence signal would be balanced. But for the average person in this study, the signal was heavily skewed towards the stereotype. This means that even when the objective fact strongly pointed one way, the person's internal feeling of evidence was dominated by the stereotype. This leads to a mismatch. or miscalibration between what the facts are and what our internal evidence signal tells us. This leads to a really important prediction. If your internal evidence signal is fundamentally biased, then just thinking longer or deliberating more might not actually help you get the right answer. In their simulations, for an unbiased thinker, more deliberation led to better accuracy. But for a biased thinker, increasing deliberation time actually made very little difference to accuracy, and sometimes even made it worse. It's like you're spinning your wheels, accumulating more of the same biased evidence. To see if this was true in the real world, they looked at data from other studies where people were asked to think twice about their answers. They found that for people who were less biased initially, thinking longer did help them correct their mistakes. But for people who were highly biased, thinking longer didn't lead to much improvement. This supports the idea that for some people, extra thinking time is like thinking in vain because their underlying evidence signal is already distorted. So, what does this all mean? It challenges the idea that reasoning biases are simply about not trying hard enough or not engaging our logical thinking. Instead, it suggests that the problem is deeper. It's about how we construct our internal evidence signal in the first place if that signal is skewed by stereotypes or other biases. Then even trying to think harder might not fix the problem. It's like trying to build a straight wall with crooked rulers. No matter how carefully you measure, the wall will still lean. This has big implications for how we try to fix biases. Simply telling people to think more or be more careful might not be enough, especially for those who are more prone to bias. Instead, the focus might need to be on changing how people weigh different kinds of information, rather than just encouraging more effort. Imagine in areas like medicine or law, where biased reasoning can have serious consequences. Interventions that help people build a more balanced and accurate internal evidence signal could be much more effective than those that just tell them to take more time. It's a really neat way to look at a complex problem. It suggests that the problem isn't always a lack of trying, but a fundamental issue with how our brains process and weigh information internally. The researchers here have given us a powerful new way to think about why our reasoning sometimes leads us astray, and importantly, how we might actually start to fix it. What do you think about these findings? Have you ever felt like you were thinking hard but still coming to the wrong conclusion? Let me know in the comments below. And if you found this dive into the mind useful, please give this video a thumbs up, subscribe to RUBIN'S MindLab for more insights into psychology, and hit that notification bell so you don't miss our next video. Thanks for watching, and I'll see you next time.